what's up guys? Welcome back. Moving on to the next question. So we have a prism here. It is bisected by the YZ plane and divided by the XZ plane such that 3/4 of the prism is in the positive Y side of the plane. Point C is 2, 6, and 7, and we have to determine these three magnitudes here, HG, FG, and HB. So first thing I'm going to do is I'm going to label point C on this prism. So we got 2, 6, and 7. And what we have to do is, using this information, using that point, we have to find out the coordinates of all the other points on this prism, and then we can go and find the magnitudes. In fact, we don't even have to find all the points. Notice how points A and D, for example, are not asked for these magnitudes. But let's just find all the points, all the coordinates anyway. So we got 2, 6, and 7 here. And notice how with this point, we can find out the coordinates of a couple of other points before even using the information in the sentence. So I'm going to start off with this point G. So we can take this point 2, 6, and 7, and we can shift it down where the Z value is going to be 0. So we know this point G here, it's going to have the same X and Y value of 2 and 6, but it's going to have a Z value of 0. And now what I'm going to do is I'm going to try to figure out the coordinates of H, E, and F. I'm going to stick to the bottom face of the prism, working with that bottom face. And notice how all of these points, they're all going to have a Z value of 0, right? Because they're all on that XY plane. Right? This point G is where X and Y are positive, but these axes, they also extend to the negative side. So that's like the negative Y axis, and then here you'd have the negative X axis. So let's reread the question and try to take in the information again, where we can use it to help us to find those coordinates H, E, and F on the base of that prism. So the first piece of information we're told is that the prism is bisected by the YZ plane. Now, bisected, if you remember, it basically means cut in half. When you bisect something, you're basically cutting it in half. So the prism is bisected by the YZ plane. So the YZ plane is over here. So notice it would just be sort of sticking out of this prism. And which sides is it going to go through? Well, it's definitely going to go through sides D and C, but we're not looking at that side right now. We're looking at the base of the prism, so it's also going through the side H and G. So it means that the YZ plane is coming out, it's bisecting this prism, so that means this length H and G, half of it is to the right of that YZ plane, and then half of that length HG is to the left of that YZ plane. And notice at this point here how the X value is 0. So an X value 0 would be right at the origin. Well, anywhere along this Y axis, the X value is 0. The X and the Z value are 0. So notice that the length from here to here would be shown by the X coordinate. Notice the X coordinate is 2. So we have an X value of 0 at this point, and then we have an X value of 2 at this point G. So that means this length here is 2. So that means that this length has to be 2 as well. Both of these lengths are going to be equal, right? The YZ plane is bisecting this line here. So if from here to here is a length of 2, what is this coordinate H, what X value is it going to have? Well, it's going to have an X value of -2, right? Because the length from here to here is 2 as well. But notice this H coordinate is in the negative portion for the X-axis. This coordinate G is in the positive portion of the X-axis. This coordinate H is in the negative portion. And since those lengths are equal, from 0 to -2, that's a length of 2 as well. And then notice this point H, it has the same y-coordinate as point G. Right? If you notice this whole line here, it has the same y value of 6 throughout. So we know that the y value of H is going to be 6. And then we also know that the z value is going to be 0. As we mentioned, H, E, F, they're all going to have z values of 0 because it's on that bottom portion of the bottom face of the prism, which is on the xy plane. On the xy plane, the z value is always 0. Right? So we got this coordinate for H here, -2, 6, and 0. Let's move on trying to find out what the coordinate for F is going to be. So if we read further, we're told that the prism is divided by the xz plane. So the xz plane would be over here, such that 3/4 of the prism is in the positive y side of the plane. So the positive y side is here. So the xz plane is dividing the prism such that 3/4 of the prism is on that positive y side. So if you notice the xz plane, it's dividing this length f and g. So from here to here, that's going to represent 3/4 of that total length of fg. And that means from here to here, that's going to be 1/4 of that length fg. Right? This portion here is in the positive portion of the y-axis, and then this portion here is in the negative portion of the y-axis. So notice that this length is determined by the y-coordinate. Right? If you look at the y-axis, that's what's determining this length here. So notice here on the x-axis how the y value is always going to have a value of 0. So from here to here, from this point on the x-axis to this point G, the length is 6. And that's going to represent 3/4 of that total length of FG. So we can actually figure out what this magnitude of FG is pretty easily. Basically, 3/4 of that magnitude of FG, right? This is FG. 3/4 of that magnitude is going to have a length of 6. Because from this point where the y value is 0 to this point G where the y value is 6, that length is 6. So basically we can just divide both sides by 3/4, get that FG by itself. 6 divided by 3/4 would give us 8. Right? So we actually answered question B in this case. The magnitude of FG is just 8. Right? So if this length is 6 and the total length FG is 8, then what's the length going to be from here to F? Well, it's going to be 1/4 of that full length of FG 8. So we know that this length here is going to be 2. And notice that that point F is in the negative portion of the y-axis. So from 0 to this point F, there's a length of 2, and we know the y value is going to be negative, so we know the y value is going to have or the y-coordinate is going to have a value of -2 at point F. We also know that the z value is 0 because it's on the xy plane still. And then we also know that that x value is going to stay constant from point G. Notice this whole line here, it's always going to have an x value of 2. So this point F has a coordinate of 2, -2, and 0. And now that we have coordinates H, G, and F, we can easily figure out what coordinate E is going to be. Notice coordinate E is going to have the same x value, same negative x value of -2 as point H. right? This whole line here is going to have that same x value of -2. Point E is also going to have the same y value of -2, right? So this whole line is going to have a constant y value. It's going through that y value of -2 the whole time. And that z value is just 0 for point E as well. It's part of that bottom face of the prism. Right, so let's erase everything here besides the coordinates, just so we're not getting confused with all this extra stuff on the graph. Hopefully you understood how I got these other points using this information. If not, you may have to re-watch that. But it should make sense to you at this point. So now that we have the coordinates of all of the points on the base, notice that we can find the coordinates for A, D, C, and B very easily because basically these coordinates are just these coordinates shifted up by 7. Right? So instead of having a z value of 0, like all of these coordinates do, all of these coordinates are going to have a z value of 7 because this point C has a z value of 7. So this point F, it's going to have the same x value 2, same y value -2, but it's now going to have a z value of 7. This point A is going to have the same x and y value of -2 and -2 as point E, but instead of a z value 0, it's going to have a z value of 7 now. And then finally this point D, taking this point H, shifting it up by 7, so same x value -2, same y value 6, and then it has a z value of 7. And now that we have the coordinates for all of the corners of this prism, we can easily find out what all of these magnitudes are. In part B, we already did that. We could have actually also did part A pretty easily, but let's just use the magnitude formula. So we're finding the magnitude of H and G. And what is the magnitude formula? Well, we basically have to take the difference in all of the coordinates. So we got -2 minus 2 squared plus the difference in the y values, so 6 minus 6 squared, plus the difference in the z value, so 0 minus 0 squared. Sum those square differences up and then square root the whole thing. That's the formula for the magnitude. Well, notice 6 minus 6 is 0, 0 minus 0 is 0, so these points, or these parts rather, will go to 0. And then -2 minus 2 is -4, squared is 16, then the square root of 16 is 4. So the magnitude of HG is 4. And we can also tell when we were doing the question where we were figuring out the coordinates for H, remember we said that the distance from here to here was 2, and then the distance from here to here was 2 as well, because the prism is being bisected by that YZ plane that's sticking out. So 2 and 2, basically the magnitude of HG, the length of it is 4. So whether you do it sort of visually or whether you do it with the formula, magnitude of HG is 4. And then part B, the magnitude of FG, we already did that visually while we were figuring out the coordinates of F, but you can also do it with the formula. So now that we have the coordinates of F and G, basically the magnitude of FG is going to be what? It's going to be the difference in the x values. So we got 2 minus 2 squared. The difference in the y value, so 6 minus -2. Remember to put that bracket there for -2. You got to square that. And then 0 minus 0 squared. And then you would square root that whole thing. So notice 2 minus 2, that goes to 0. 0 minus 0, that's 0. 6 minus -2, that is like 6 plus 2, which is 8. Squared is 64. Square root of 64 is 8, which is what we got when we did it visually. All right, so either way works. Basically, the way we figured it out, if you remember, the XZ plane divides the prism where 3/4 of the prism is on that positive portion of the y-axis. So this here, if you remember, was 3/4. And then the distance from here to here is basically the distance from a y value of 0 to a y value of 6. Right? So if we take 6 divided by 3/4, we got that full distance of FG, that full length of FG, which was 8. And then the toughest one, we have to find the magnitude of HB. And now this one, you can't really do visually. So for this part C, you actually had to get the coordinates of H and B. And that was probably the trickiest part of the question, getting those two coordinates. And for this magnitude, can't really do it visually. You have to use the magnitude formula. So we would take the difference in the x values, so 2 minus -2, square that difference. Take the difference in the y value, so -2 minus 6 squared. And then the difference in the z value, so 7 minus 0 squared. Then we would be square rooting that whole thing. So what are we going to have here? Well, 2 minus -2, that's like 2 plus 2, which is 4. 4 squared, 16. Then we've got -2 minus 6, which is -8 squared, that's 64. And then 7 minus 0 is 7 squared is 49. Let me just add up all these. So 16 plus 64, that's 80, plus 49, that's 129. Square root of 129. And I don't think that that simplifies any further, if I'm not mistaken. So that is the final answer there. Root 129 represents the magnitude of HB. Right, and notice how it's sort of an ugly number. It's not smooth like these ones. Because these were pretty smooth, 4 and 8, you're able to see it visually. This one, like I mentioned, you can't really do visually. You actually have to get the coordinates of H and B to answer part C, the magnitude of HB, which is the root of 129. So, pretty tricky question, in my opinion. You have to really read this information carefully and use the information to get the coordinates of the prism. Then once you have the coordinates, you can go and answer A, B, and C in finding the respective magnitudes.